Welcome to AI and Machine Learning Deep Dives. So today, we're going to tackle a problem that, trust me, trips up pretty much everyone at some point: overfitting in random forest models. You know the feeling. You build a model, it looks absolutely perfect on paper, but then it just falls apart in the real world. We're going to break down why that happens and, more importantly, exactly how you can fix it. So you've been there, right? You build your random forest, you check its performance, and the numbers, they look incredible. Almost too good to be true. But then, the moment you unleash it on some new, unseen data, the results are, well, pretty disappointing. This whole frustrating scenario is a classic sign of a very specific and very common problem. All right, so let's start with the number one warning sign. That classic symptom that should immediately tell you your model's amazing performance is probably just an illusion. You see something like this. On the left, a phenomenal training score, maybe at 99% accuracy. You're feeling pretty good. But then you look at the right, and when the model faces data it's never seen before, that accuracy just plummets down to something like 77%. This huge performance gap, that's not a success story. That is a massive red flag. So what is overfitting, really? Well, it means your model hasn't actually learned the general rules from your data. Instead, it's basically just memorized the training set. And I mean everything, including all the random noise and weird quirks. It's kind of like a student who crams for a test by just memorizing the answer key. They'll ace that specific test, but they'll fail any question that's even a little bit different. This leads to what we call high variance, and it makes the model's predictions really unstable on new data. That brings us to takeaway number one. This big gap in performance isn't just a number. It is the clearest possible signal you're going to get that your model has memorized the past instead of actually learning how to predict the future. And this is where things can get a little confusing. Because, wait a minute, many of us were taught that random forests are supposed to be designed to prevent this exact problem. So what's really going on here? You've probably heard this before, right? This claim that random forests don't overfit is a huge reason why they're so popular in the first place. But, the reality is just a little more nuanced than that. Now, the model's core design, it's brilliant. It fights overfitting with two really powerful layers of randomization. First, you've got bootstrap sampling, which means each tree in the forest only gets to see a random sample of the data. And second, at every single decision point or split, the tree only considers a random subset of features. These two things together force all the trees to be different from each other, which is the key to reducing the final model's overall error. And here's the crucial insight, the thing you have to remember. While the forest as a whole is robust, the individual trees are not. See, by default, each tree is grown to its maximum possible depth. It becomes an absolute expert on its own little piece of the data. And that means each tree on its own is actually highly overfit. The wisdom of the crowd from all the trees averages out this problem, but it doesn't always eliminate it completely. That brings us to takeaway number two. Don't get complacent. Random forests are designed to resist overfitting, that's true, but they are absolutely not immune to it. Especially if you just let those individual trees grow way too complex without any checks and balances. Okay, so this brings us to a really, really critical part of the process, and one that's honestly overlooked all the time. You have to make sure you're actually measuring your model's performance correctly in the first place. The number one mistake I see people make is checking performance by feeding the training data right back into the model. That's what we call the in-bag score, and it's like giving a student the exact same test they used to study. Of course they're going to get a perfect score. It's misleading. The correct way, the right way, is to use the out-of-bag, or OOB score. It's calculated for you automatically using the data points that were held back from each tree during training. This gives you a much more honest estimate of how it'll do in the real world. And the difference is, well, pretty stark. When you switch from that misleading in-bag score to the proper out-of-bag method, your score might drop from that perfect 99% to a much more realistic 87%. Now, this isn't a failure. This is clarity. This is an honest number you can actually trust and work with. That brings us to takeaway number 3, and it's a simple rule to live by. Always, always use the out-of-bag score. Think of it as your golden rule. It's your most reliable, most honest way to measure your model's performance without the bias of testing it on data it's already memorized. Okay, so you've used the OOB score. You've confirmed your model is overfit. Now what? How do you actually fix it? Let's look at the key levers you can pull to start tuning your model. You've got 3 main tools in your toolkit to control complexity and tame those overgrown trees. First is MC Tree, which controls how many features are considered at each split. Second, you have max_depth, which puts a hard limit on how deep your trees can grow. And third, there's MinSample's leaf, which stops the model from creating tiny, super-specific leaves for just a few outlier data points. That brings us to our final takeaway, number 4. Don't just accept the default settings. Actively tuning these hyperparameters, mtry, max depth, MinSample's leaf, this is the most direct and powerful way you have to constrain your model, to reduce its variance, and to build a forest that performs well not just in training, but out there in the wild. All right, we've covered a lot of ground here, so let's do a quick recap of the 4 key takeaways for taming your random forest and getting it under control. First off, that huge gap between your training and test scores, that's your big warning sign. Second, remember that random forests, even with their clever design, can and definitely will overfit if you let them. Third, and this is a big one, always use the out-of-bag score to get an honest check on performance. And finally, number 4, get your hands dirty. Actively tune those key hyperparameters to control the complexity and build a truly robust model. So, I'll leave you with this question to think about. Now that you can spot the signs, diagnose the real cause, and apply the fix, is your next forest truly ready for the wild? What steps are you going to take to make sure your next model is built not just for high scores, but for true generalization? That's all for now, folks. Please like, share, and subscribe for more like this.